In this video, I'll be diving deep into different LLM parameters which controls how LLMs generate response. So I'll be discussing temperature, top P, top K, and many more. And we'll take a look at practical examples to see how changing the values for these parameters alters models' responses. And we'll also try to understand when should we use each of these parameters in real world applications. So let's get started. So firstly, I'm doing the setup. Here I'm using Olama, which is a free library, and I'm using the Llama 3 model here. But you can use any of the OpenAI's API or Anthropic API if you have access to it. Then your syntax might look a bit different from mine, but the underlying concept is the same. Here I have defined a ask method which takes in the prompt along with the keyword arguments, and keyword arguments are basically all the parameter settings that I want to send to the model in order to be able to generate response with those parameter settings. And here I'm just making a call to the generate API to get the model's response for my prompt. So before diving deep into all of these parameters, let's try to understand what a context window is. So a context window is basically the maximum number of tokens a model can process at once. It consists of three things. First is the system message, which is a special message that sets the tone, constraints, behavior of the model. Second is the user message, which is the actual task or query that you are making to the LLM. Third is the assistant's response, which is the actual model's response, right? So here I have listed a couple of models along with their context window sizes. Nowadays, most of the models come with context window size of at least 1 million tokens. Why the context window size matters a lot is because if your context is too short, then your model will not have enough information to come up with an appropriate answer. If it is too long, then it requires more computation, which means it becomes more expensive and slower. And it has lost in the middle problem, wherein the model understands the start and the end of your input, but has no context of what is going on in the middle, which leads to models coming up with some random answers or hallucinating, right? So here comes the concept of context engineering, which is basically a system design approach to designing the models in a way so that it only gets context which has the most relevant information, and all the irrelevant information is removed from it. Context engineering is a completely different topic. I'll be discussing that in a separate video. But for now, just understand that it is different from prompt engineering. And here is a tokenizer playground that you can use to check how your input gets tokenized. You can select the model that you're using. I'm using Llama 3, so I've selected that and I've just put in one random sentence to see how the words are being tokenized. And you can see for most of the words, they are converted to each different tokens, but for this word quotidian, it's converted into two different tokens. So why it is done is because when LLMs are being trained, they come across a lot of these common words, but for uncommon words they have to break it down into words which they have an understanding of. So they'll break it down into multiple words which LLMs have learned while it was being trained. Okay. So now coming back to the context window, here I have put an example to show you how the context window keeps growing when you are chatting with an AI assistant. So I have tried to create a small AI assistant which maintains the conversation history, and I'm also printing the token count here. So firstly, I fire the LLM with this statement that my favorite programming language is Python. And if you see here, the token count after this query was 67. And then I ask it something unrelated, and the token count increase, and that is how the context window keeps on increasing. And later I again asked the LLM what is my favorite programming language to check if it's actually remembering the context or if it is there in the context or not. And as you can see, it says, I remember your favorite programming language is Python. And yeah, that's how it keeps on putting everything in context, and that's how the context window keeps growing, and that is why context engineering and all of these things are becoming popular. So that's about it for the context window. Now let's move on to the different parameters that controls how the models generate responses. So let's start with temperature. Temperature basically controls the randomness of the model's response. So if your temperature value is 0, that means it is fully deterministic, meaning it will always pick the token which has highest probability. So what it means is that if I have a sentence like the sky is, and I want the LLM to complete it, then LLM might come up with few tokens which it can fill in here. So let's say it comes up with tokens like blue, green, red, yellow, and then some random word, let's say cloudy, and so on and so forth. So LLM will assign probabilities to each of these. So let's say it assigns a probability of zero point 0.6 to blue, and then to green, let's say it says 0.2, 0.1, and 0.07, and 0.09, and etc. etc. So now when the temperature setting is 0, then it will always pick the word which has the highest probability, which in this case is blue, right? But as you keep on increasing the temperature setting value, the randomness keeps on increasing because it can then choose from any of these words. So the more the temperature setting value increases, so let's say you increase it from 0 to 0.1, so then it will maybe have a scope of selecting the token from these two. If you increase it to 0.7, then it will maybe have scope to select from all of these. And if you, let's say, go beyond 1.0 to 2 between 2.0, then it will maybe select from all of the words that are present. So as you keep on increasing the temperature value, the number of tokens that it can select from here keeps on increasing, and hence the randomness keeps on increasing. So before, when the temperature value was zero point 0.0, it could only select blue, which was very factual answer at that point of time. But as you increase the temperature, it could say, okay, the sky is cloudy today. So that's how the temperature values influences the model's response. So basically the intuition is that lower temperature value model is confident and deterministic, but for higher temperature values the model is creative and explores more number of tokens. Right. So here is a list of different cases that different temperature values can be used for. So for deterministic tasks, it's good for factual question answers and math problems, coding, and a little bit higher temperature value for summarization, Q&A. For very high temperature values, it's good for poetry, brainstorming, etc. Here I have demonstrated example where I'm asking the LLM to write a one sentence tagline for work for coffee shop, and using different temperature values for this, and you can see for yourself how creative the LLMs become as the temperature values keep on increasing. Now moving on to the next parameter, which is top P. So what is top P? Top P basically says that instead of selecting the most probable token from all of the tokens, select the tokens whose cumulative probability score is equal to the top P value. So if the top P value is 1, then all the tokens will be considered, right? Because ultimately the probability score for all of the tokens combined, or cumulative probability for all of these tokens, is equal to 1. So when it is 1 means consider all of these tokens. When it is zero point 0.8, then you consider from a set of tokens whose cumulative probability is equal to zero point 0.8. So let's understand this by taking a look at the previous example that we took for the sky is blue. So here we have probabilities, and if top p value is equal to zero point 0.8, then it will say that okay, get all the tokens whose cumulative value is equivalent to zero point 0.8 and choose from that. So now the set of tokens is limited, right? If you lower the value, then it will get more limited and more constrained. So the lower the top p value is, the model becomes more deterministic, and the higher the top p value is, the model becomes more creative and has more options to choose from. Again, coming back to this table, if the top p value is 1.0, then it will consider 100% of the tokens. If it is zero point 0.5, then it is very focused, only limited to certain tokens. If it is zero point 0.1, then it is extremely focused. Okay. Again, I have taken a very interesting example here, saying to the LLM that give me an excuse for being late to work, and I'm providing the top p values, which is zero point 0.1, 0.5, 0.95, and you can see as you increase the top p value, the model will start getting more creative, because then it will have more number of tokens to decide from. So you will see that it says I spilled coffee all over my shirt and had to stop and change, while if you see the response for zero point 0.1, it will be more like normal response that okay, my car was not starting and stuff, right? Now coming to top k. So in top p, it limits to the number of tokens whose cumulative probability comes to a certain value. In top k, you're actually telling the model that okay, use only top 10 tokens. So if the top k value is 5, then it will consider one, 2, 3, 4, 5, like the first 5 words, and predict the next probable token from these 5 tokens only, right? So that is the difference between top K and top P. Top K has fixed number of tokens. Top P does not have fixed number of tokens, right? It depends on the top P value. So if the value is more, there will be more number of tokens. If the value is less, there will be lesser number of tokens. So yeah, it depends on that. So top P is much more adaptable, and that is why it is more preferred. If the top k value is 1, then the model is very deterministic. Top k value is equal to 50 more, then it's considering from a large number of tokens, so it's more creative and more non-deterministic. Right, again, I'm using the same prompt as I used for top p, which is give me an excuse for being late to work. And you can see that as the number of tokens increases with the top k value, um, the model becomes very creative. So it says that I left my favorite coffee mug at home, that's why I got late to work. So now moving on to the next parameter, which is max tokens. So max tokens is basically the maximum number of tokens that you want your model to generate. So for example, there can be different use cases for which you might not want your model to generate unlimited number of tokens and just waste your context window. So for example, yes, no answers, you can limit your model to only respond with 5 to 20 tokens. Same goes with other use cases as well, and you can limit it based on whatever max number of tokens you want for that. So in the API that I'm using from Olama, max tokens is referred to as num predict, so don't get confused. But in I think OpenAI and Anthropic's API, it's max tokens only. But yeah, so here I'm using, here the prompt is write a 200 word essay on the ocean, and I'm using different max tokens like 20, 100, and 300. And you can see that for max tokens 20, it actually stopped in between. just because the max tokens provided was 20, and I've also tried to print the stop reason which says length. And for 100 also, you can see it just stopped in between while it was generating the answer. That is the whole point of max tokens. While for 300, it was able to come up with a full answer as we asked the LLM to write a 200 word essay, right? So here the stop reason was different from the stop reason that we had when the max tokens count was less than the count that LLM was generating. Next parameter is stop sequences. So stop sequences are strings that tell the model to stop generating as soon as that string is produced. So it is used for a lot of structured output generation. So for example, if you have a JSON being returned from LLMs, you can ask the LLM to stop as soon as it encounters a closing bracket, right? Similarly, you can do it for any kind of delimiter that you have in your output, or if there's a new line, you can stop your LLMs from generating the responses. So again, here I have taken a example saying answer the question, then explain your reasoning, and this is the question. And I've demonstrated without stop sequences. You can see that it generates the output along with the reasoning. While when I have said that, okay, with stop sequences, stop when you encounter a new line. So as soon as it encounters a new line, it just stops generating the response. So it only just comes up with the answer and doesn't comes up with the reasoning. In the next section, I've tried to combine all the parameters that we have learned and use it for real world use cases. So I have defined a helper method get config, wherein the config contains configs for different use cases. So for example, for code, for creative writing, for Q&A, for extraction, and here for like code we have temperature settings as zero point 0.0 because we want the model to be deterministic, and for the creative we have temperature settings higher because we want the model to be creative and choose from like a large number of tokens. And similarly, there are other parameters that you can adjust based on your use cases. For Q&A, again, the temperature is low because we want the model to be uh, factually correct, whereas the top P is higher. Maximum number of tokens is also less because we don't want the model to keep on generating the answer like very long answers. And yeah, so based on your use case you can alter these parameters. And here I've demonstrated like the code generation use case, which is using these parameters to generate the code. And there is brainstorming, which is basically the creative use case, which is using the creative config, and so on and so forth. So this is the Q&A use case, and which has a limit of 300 tokens. And this is the data extraction use case, which is generating the structured output. So it will have a stop sequence which stops the response when there's a uh, new line encountered or something like that, so that it can parse the outputs, right? Here are a few takeaways from this whole discussion, that temperature is your primary creativity dial. So if you want to be creative, use temperature settings. For top P and top K, you can refine your token pool. So if you want to limit or restrict from the number of tokens or based on the probability scores of the tokens, then use top P and top K. Usually it's recommended that you use one at a time, right? Max number of tokens controls the cost and limits your context window from being over flooded. So do use max tokens if you don't want your context window to be flooded with unlimited responses. Stop sequences are essential for passing structured outputs. So if you learned something from this video, then don't forget to hit like and subscribe to my channel. Thank you.